Hello, today I'd like to talk to you about graphing logarithmic functions. A couple of things that we can go through and try and help this process along, and hopefully by the end of this we're going to get through one example only, I think, in this video, but I think going through the process of what to do and then actually going through and doing it, we should be in pretty good shape. This is our basic form of a logarithmic function. Now, you've seen these kinds of setups before. There's an x minus an h, and this is going to do a horizontal shift. There's a k, and that's going to do a vertical shift. Our a is going to stretch things out, and how it's going to do that. And it possibly could flip things over if it were negative. And b is just kind of the index here that we have on the logarithm that we're working with. Let's kind of take a look at some of these things and see how they're going to affect our logarithm. I first want to start looking at what this x minus h is going to help us find. And it's going to help us find two different things. One, it's going to help us find the vertical asymptote. Okay, our vertical asymptote. And the second thing it's going to help us find is our domain. Okay, our domain. Those are the two things that it will help us find. And here's what we're going to do. We're going to take that x minus h, we're going to set it equal to 0 and solve for x. In this case, it's an x equals an h, and that's going to give us our vertical asymptote. Well, as long as we don't have a negative h happen, a negative x in there, if it's an h minus x, then these things kind of get changed around a little bit, but we're not going to deal with that, I don't think. As long as we're not dealing with that, then x has to be greater than whatever that value ended up being, and greater than h. So that's how we're going to find our vertical asymptote in our domain. Now, had there been a 2 or something like that in front of here, some other number, then it's not going to be just h, but it would be h over something else. What are some of these other letters and numbers in this case going to do? Well, a is going to stretch this thing vertically, and it could flip it over. So a is going to show us if a is positive. Okay, if a is a positive, this is going to start low and it's going to then increase the whole time. If a is negative, then the function is going to start high and decrease the whole time. So once again, if it's positive, if a is positive, this up here is positive, it's going to start down low and it's going to increase. Our graph will end up looking something like this. It'll start down low and it's going to just kind of increase like this. On the other hand, if it's negative, it's going to start high and it's going to decrease. So it's going to start up high and it's going to decrease like this. Now, you can see perhaps looking at what we have drawn here, our vertical asymptotes showing up. Okay, and that's what we're going to start high or low against, and then we're going to kind of go off until infinity. Now what I want to look for is the turning point. In either of those two graphs, as we went along that asymptote, and then we just kind of turned and increased, somewhere in here, it's always turning. And that's why we have our turning point there in quotes. But if we look at when x minus h equals 1, we're going to find some good things. All right. And when x minus h equals 1, our y value will end up being the k. So we'll take a look at this. We'll get our x equals our 1 plus an h in this case, and our y value would be our k. So our turning point would be whatever that 1 plus h is, and we should have a numeric value for that by that point in time, and whatever that k value was at the end of that function that we saw. Let's try graphing one. All right, our vertical asymptote, if you remember, we're going to take our x minus our 1 and set that equal to 0, and we'll find out that x equals 1 is our vertical asymptote. Meanwhile, our domain is going to take that same 1 into account, and remember, we're going to be bigger than that. The only way that's going to be smaller ever is if we end up with a negative x up in here somehow, and I think we'll probably stay away from those for the most part. The next question is, what is our a value? Well, a equals 1 in this case, and 1 is positive. So if it's positive, it's going to start low and increase the whole time. We're not going to start up high and come down. We're going to start low and increase. So what we should know right now is we're going to have an asymptote vertical at the line x equals 1, okay, and it's going to start low and it's going to increase. That's our look of our graph, even right now, before we do much else. But it would be nice to know a little bit more. So let's find our turning point. And our turning point, remember, we're going to take this x minus 1 and set it equal to 1, and then solve for x. So our x value of our turning point is going to be 2. So there's our 2. Our y value for our turning point is also going to be 2, but for different reasons. It's this 2 right here that we're going to use for our y value. Now, if you think about that for a minute, what happens if I plugged 2 into the function? If I plugged 2 into the function, I'd have f of x equals log base 3 of 3 plus 2. And anytime you have a log base and what you're taking the log of exactly the same, remember that's going to be a 1. So this is like saying, so that's where we get our 2. Now, I had to undo a little recording, and I'm not sure exactly what yours is going to look like. But I wanted to plug in this 2 value, the 2 for x, and see what happens when we plug that in. I shouldn't say f of x, I should say f of 2 is equal to log base 3 of 2 minus 1 is 1 plus a 2. Well, log base anything of 1, anything to the 0 power is 1, so that would be a 0 plus a 2, and that's where we get that 2 from, if you wanted to go through and plug it in. Now, let's go find 2 more points. I picked 2 points here. I picked 4 and I picked 10, and there's a reason why I picked 4. If I do f of 4, I will get a log base 3 of 3, 4 minus 1, plus a 2. Log base 3 of 3, 3 to what exponent will give you a 3? Well, that's a 1. So we add a 1 plus a 2, and that gives us a 3. So that's going to give us the point 4, 3. If we take a look at 10, once again, I'm careful with the points that I pick. If I do f of 10, yeah, we're getting into bigger x values, but if you think about what we're going to get out of this, we're going to get a 10 minus 1, so a log base 3 of 9 plus a 2, and I can change that 9 into a 3 squared. So I have a log base 3 of 3 squared plus a 2, and I can drop this squared down in front. So I have a 2 log base 3 of 3 plus a 2, and we just said a minute ago log base 3 of 3 was 1, so this is really like saying 2 plus 2, and we should know that 2 plus 2 is 4, giving us the point 10, 4. Let's take these 3 points and our asymptotes and everything else that we've learned and put them on a graph and see where that puts us. All right, so here's our graph, and I've written down a lot of the things that we've learned already. We've got these extra points that we just found, our turning point that we found, we have our asymptote that we had, and we know that it starts low and increases. Those are really the things that we're going to use to make this graph. Now, if I can draw in this asymptote as best I can here, it's a vertical line. It's not part of the function. Remember, I'm getting a little bit off that line, but I'm doing my best. Give me some credit here, okay? There's our asymptote. Now, from that point, we want to graph our function. Our function is going to start for us. We're going to put the point 2, 2 on our graph, and we're going to go from there. So let's see. We have the point 4, 3. So 1, 2, 3, 4, 3, and we have the point 10, 4. So 4, 5, 6, 7, 8, 9, 10, 4. And you can see how this graph is going to go off in this direction. And since we have that asymptote there, we can see that as it comes around this corner, it's going to be going down in this direction. Now it should be going a little bit more to the left as we go down. And now my asymptote's a little bit off, but there's my function. It's not going straight down. It's going a little bit to the left every little bit that it goes down. And there's my graph. You can see my domain. All my x values are on this side of the line that we had. And there's my graph. It should look somewhat similar to the exponential graphs that we had before, and they should be inverses of each other, so that makes sense. They should be reflected over the line y equals x. I hope this is helpful. You always have other options for graphing as well. You can make an xy chart and go from there, but I think knowing their domain and knowing your asymptote and kind of finding this area right in here where it's going to kind of do a bulk of the turning is very helpful in graphing these logarithmic functions. I hope this helps.